Okay, now, once again, when the monocytes pick up something that they can't control, in other words, like they can't actually get rid of it themselves, they can push a little piece of it, put it on their membrane, make their way to a lymphocyte. This is why they're called an antigen-presenting cell, because an antigen is something that is foreign within the body. Okay, so we've got our natural killer cells, we got T cells, we got B cells, we got macrophages, we've got dendritic cells. Dendritic cells, these are going to be branched cells, and they are going to be the mobile, moving APCs, antigen-presenting cells, that can be found in, think about mucous membranes, the epidermis. Their job, okay, once again, alert the immune system to any pathogens that might have breached the body's surface. Think about something as simple as a paper cut, okay? Because that has breached the body's surface. The skin is our first line of defense. So having these cells be present in this area, anything that breaches it, they're going to try to make sure they take care of it. So, engulf foreign material, if needed, by receptor-mediated endocytosis, meaning as a cell, they'll have receptors, okay, of a certain structure. If the material can fit into that receptor that they have on their cell shape, on their cell membrane, okay, they engulf it and hopefully get rid of it, okay? Now, if not, migrate to the lymph nodes nearby and activate my immune response. So the cells that have to make their way to a lymph node are going to be activating what is termed in our bodies the immune response. That is something totally different than just anything that's very simple that can happen, all right? We're going to find that we have these lines of defense. So, the very last one is when we have to activate the immune response. So that's the last line of defense that the body has. Anything that breaches that, ooh, we're in trouble, okay? Reticular cells, these are ones that are going to simply be stationary in the lymph organs. So, once they're formed, they'll migrate to a lymph node because of that structure of a lymph node being reticular tissue that looks like webbing. These cells go, get stuck in one of these webs, and they just sit there. And as stuff comes by, and they just stay in lymph node. So we've got all these different types of cells that are going to help us with our lines of defense, because we have 3, okay? So, when we talk about this system, we're going to say we have lymphatic tissue and aggregation of clumping That's what that means. Of lymphocytes. I'm trying to point out very, very much. We have lymphocytes. T cells, B cells. Everything else, monocytes. Okay? So, when we say lymphatic tissue, this is a clumping together of my lymphocytes in mucous membranes and other organs of the body. The most simplest that we have is termed diffuse. Kind of a webbing type structure, very diffuse, okay? Meaning scattered around. One area that we need a lot of this, anything that is an opening to the exterior of the body. So think of any passageways that we have that are open to the exterior environment. We're going to find tons of these cells present because these openings that we have to the exterior environment are getting exposed to everything that's out here. For example, cold virus, flu virus, all this sort of fun. Y'all thinking about that this time of year? No? Okay.
Who thinks about viruses?
Huh?
Who thinks about viruses?
I do. It's the flu season. I do. Yeah. You don't see me touch door handle. You don't see me like just freely go up and just work the handles or work door handles or do anything. I've got a piece of paper. Because I don't get the flu shot and stuff like that, So I feel like decrease my chances as much as possible. When we talk about a lymphatic nodule, okay, and love that term, nodule, okay, sounds like something from Gilligan's Island or whatever. A dense mass of tissue. This is an area that my lymphocytes, T cells, B cells, okay, and my macrophages, the ones that can become an antigen-presenting cell, can congregate. This is what we find. For example, my lymph nodes, think about this area, tonsils. I have a student one time like, can you feel my neck? I'm like thinking, okay, I'm not that kind of doctor. And okay, I could do that, and I could tell you if the lymph nodes are swollen or not, but it's like I'm not that kind of doctor. Okay, so you would need to be able to go to the doctor and let them take over and see what's happening. Now, note, we have something called Peyer's patches that are going to be found in my digestive system because we need some extra, this protection because of all that we are exposed to in our food sources. So in the area of the intestines, we're going to have something that's termed Peyer's patches. The organs are very well defined in this lymphatic system. We're going to see that we have our red bone marrow. Why?
Red blood cell production?
This is the area, what?
For red blood cell production.
What system and what cell am I now dealing with? Not my red blood cells.
White blood cells.
My white blood cells. This is the area of production for the white blood cells. Remember those colonies that I talked about? The colony forming units? We had the one that big stem cell gave rise to for lymphocytes, and one that was giving rise to monocytes. Does everybody remember that? These are the cells, okay? These are those white blood cells. In my endocrine system, the thymus gland, because from infancy until probably 7, 10, the thymus gland is huge, huge, all right? It's taking up the majority of this thoracic region. Because why? From the time the child is born, what are they being given? Oh yeah, they're getting vaccines from the day they're born. I mean, the vaccines that children get now, compared to like when I was growing up and when I had my son, is staggering to me, okay? The goal, first of all, why are they being given at this stage of life? Got to have time to build up the antibodies. Okay, susceptibility, I'll give, okay, there, yeah, okay. This is the point. The thymus gland is the largest. This is the point when the white blood cell production that will get formed in response to the exposure that they're being given, okay, that it can go to the thymus, these T cells can go to the thymus, mature, and have a memory of whatever they tried to fight. So if the T cell gets formed, matures in the thymus gland, makes its way to a lymph node, they're given a vaccine, exposed to something, hopefully the body's going to build up an immunity to whatever they were exposed to, and the T cell sits in a lymph node with the memory. B cells also. So at this point, you're stimulating production of T cells. Okay? There's a lot of stimulation of T cells from infancy until probably early 20s. After, but as the child grows, that thymus gland is involuting, getting smaller, smaller, to the point where, if you live long enough, it's just a teeny tiny little hard pebble in your chest, okay, where it's not producing, you're not, because by the time you get older, hopefully your body has built up immunity, okay? So it doesn't have to keep doing its production. Hopefully T cells have matured, they have encountered the pathogen, they've taken care of it, they've created the memory cell and are simply sitting in a lymph node waiting. Is that mine? No. Hold up. No, that was not mine either. That's mine. Woo! Go. They fight it, you never even get sick. Okay? Every time they're given a shot, that's the goal. Okay? Natural immunity is good too. keeping them hidden away